So Alivia is a junior studying computer science at the University of California, Davis. Her journey into software. Oh, can you hear me? Her journey into software stemmed from an understanding that the healthcare industry is trying to find technological solutions to its many problems, but has a long way to go. Alivia was a pre-medical student, and after spending a summer doing biomedical research, she understood that the work she was doing could and probably should be have been virtualized. Alivia spent so much time understanding the medical field, her path in computer science was non-traditional. She took some time away from school to complete 2 boot camps, Step Boot Camp and General Assembly, on scholarship, to understand the fundamentals of web development. Olivia is also a current Code 2040 member. Shout out Code 2040. Summer fellow working as a data analytics intern at Intuit on the categories. I'm just going to skip that. There it is. She is trying to understand what questions she should ask about the data to find ways to improve products being shipped to customers and make current algorithms faster. What do you think?
A lot of people throw the name around, but a lot of people don't know what it is. And so I finished an internship at Intel where I worked on a big data project, but they didn't even know it was a big data project. I know it now, so we're going to kind of walk through that. It's like, what is big data? You guys see this little picture with some analytics and graphs and stuff. So you can read that. Basically, we're talking about a lot of data, but like a lot of data, like just a lot, right? Like, man, it's so much. Like, where do you get this data? Like, what is the data made up of? So when you think about like a company, like, so the examples that I kind of like planned out are, we're gonna think about Nike because I like my Nike phrase. So yeah, so there's like all these different parts of like the business, right? And so if I'm thinking about like Nike, and then you were to think about like, okay, so like what products does Nike have? Like where is Nike like making their money, right? So you could look at like the financial statement and start to see like, all right, like shoes, they sell more shoes than anything else in America. So when like product groups are thinking about where are we going to invest our money, and like when we need developers to build solutions, we want to like build solutions that are going to make the company more money. So those are the products that we're going to build. So like right now at Intuit, I'm working on categorization because the product Mint is very important, and more users like care about having accurate categorizations on their bank statements, right? So when you're thinking about data solutions, there's a lot of data there, right? Like Nike has all these different parts that make parts of the shoes, but if you look at the financial statements, you can see like, oh, man, so this is actually the specific product that makes the most money, so you start to look at that specific data. Yeah, right? So you can also think about like how that product is being used, so, like the shoes and this, I found this cool article on, I think it was Medium or The Verge, about how someone was like using their Nikes and like when they run the most. Yeah, so that's kind of interesting, and you can like find that type of like analytics to help you make decisions about like, okay, so which part of the data is important? So we know like shoes, we know they're used for running at this point, right? All right. And then even when you're thinking about that, it is really useful to go through this process where you're like, how does it all fit together? Because this is what I did not do initially. Initially, my product group gave me a project, and they're like, all right, so we need you to build this API on our server. But the company only has one database. Intel's a cool company. They only have one database, right? All the data from forever is in that database. So when they say that, they're like, go find the data for this product from forever, right? So I had to like, I was reading tables that like nobody looks at. Nobody goes there. It's in a dark place, right? And there's only like one guy who like knows the database. He's like the dude. You like go talk to him. You know. Like notebooks and notebooks and product, these are like the specs about that product, and then the database has like this just sinkhole of data about that product, and you're like trying to put all of that together. So when I'm talking about like a database, this is like ideal where you have like more than one server and they're like talking to each other. This is not how it was. They had one database. This is ideal. So they told me, they're like, yeah, go talk to our database team. And it was like this. That was. And when I ran my queries, there were crashes. Computers stopped, and like things did not work. So this is ideal. That's not how it is when you get there. And then inside the database, when you think about how the database looks, this is what the data looks like. Except this might be like a personal project. Think about that as like a trillion. That's how the database that I refer to. This is like a trillion. This is like a gummy bear. It's like a drop of rain. It's not like this. This is so tiny. There's like a million of them. All right. So when you're thinking about like generating revenue based on that data, like you want to make a decision like, okay, so here's what we know. Like my product group had a specific ask. They're like, all right, so we're putting this thing into products that are shipped to like billions of things that we're actually building, but are we putting pieces into that product that we really don't need? Because if so, we're wasting money. And we're not talking about like one product. We're saying like many versions of that product. I mean, it's a lot of money to continue to put something into production that does not just be there. So when you're talking about data and like making a decision like that, it can really cost a lot of money over time. And so when you get a project like a big data project, even if they don't know it's big data, you have a project manager who will give you like a project plan, and they'll be like, okay, in sprint 1, I want you to have this. In sprint 2, I want you to have this. In sprint 3, and then you're like, this all sounds really great. This is wonderful. Now we know exactly where we're going to go. I know the steps I need to take. I know all this stuff. You have this really pretty like project management document. You have this other person who did not look at the tech stack and did not try to build the thing, and there's you who has to go back to that mind map and say like, this is what I wanted it to do, but how am I gonna like, when I want to look at data for one thing and I get a billion records back, like the ask for sprint 1 was like compare across multiple products. I only got one and I crashed it. Like, what am I supposed to do now? So what data is needed according to the plan? And then you go back to this. Even though that project plan, it looked really precise, they gave it to you. They're like, build this thing. It's going to be so simple. You know what it's like. 56 notebooks look like this for me. Just for this one project. Okay. So talking about like moving relational database management systems into Hadoop. So most databases that you guys are probably familiar with, if you're building things, you're talking about SQL or NoSQL databases, maybe on like a Microsoft SQL server, some other like Oracle server, right? Those are the regular like back end for whatever product you might build. But when you're talking about like big data, like you have a lot of data, you need to like move into distributed systems and Hadoop. So the first part of that is kind of like talking with, there's so many different names for this, but I'll just like term it like a data engineer who could replicate your data and move it into the Hadoop distributed file system so that you can work on clusters in different nodes. I think that's the next slide. Oh, and then there's all of these like apps that are built in like technology. Like if you've heard anything about big data, you might start to think about, oh, I've heard of like Hadoop, but what is Hadoop, right? You might hear data scientists just throwing around like, yeah, Apache this, Apache that. And then you're like, one person might be like, yeah, I use Hive, and it took me like 3 weeks to run my data. And another person's like, yeah, use Spark, it took me 20 minutes. And then they're like, oh, yeah. So there's all these tools that you can use. Everyone has like differing opinions about how to use them, like which one's faster, why is faster, and there's a lot of them there. I'm new to that stuff, but it doesn't matter. Yeah, so if you're talking about like how it all looks together, you basically have like Hadoop as like your bottom layer, in the middle there, and like all these other tools that kind of go around and work with it. So then, once you've kind of decided, all right, so my data's in Juke, I figured out like some way that I want to ask some question about it at this point because you've been looking at it, you still have that project management document that hadn't asked. And you find some sort of way to come up with even a small question about that data, and you start to ask it, mostly via SQL, like all of those other tools that we talked about in the last slide, they're basically built off of SQL. That's like what it's built off of. So you can start to ask questions, and this is kind of like SQL queries at this point. You can start to run some queries and process some data. We haven't gotten into the back yet. We just kind of like wrote the queries. And you want to come up with data visualization. So like right now, the team that I'm working on, we're presenting our visualizations using Tableau. There's a lot of other cool tools like D3. That's one D3 is great. That was great. All right. So one of the biggest takeaways that I've gotten through this process is like keep asking questions. Like something that was really, really funny is I go into like my first meeting with the database manager, right? And he knows all these things that I don't know, but he also has like a lot of other things on his plate. Like I'm coming in as like this really small fish, I'm the intern, so he's like, yeah, whatever, she'll ask some questions, so then she's get out in like 20 minutes, so I'll just answer whatever she asks. So he'll just answer my question, but it's kind of like answering it and then not really answering it, like saying things, using terms that like I didn't understand, and sometimes he didn't understand, and then just kind of like shooing me away. And so then I'll come back with my notebook like, yeah, you said this, I looked it up, this doesn't make sense. And he's like, I know, I was tired that day. And really like dissect it down until you understand it, until you're like, I know how to spell cat, C-A-T. And you say to the other person, how do you spell cat? And they're like, C-A-T. You're like, we're on the same thing. Yeah. But keep breaking it down because like otherwise the runaround will happen and the things that you think you know and you thought you knew about the data because you saw it. So effective communication, like, oh man, so whatever data you have, someone organized that system, someone wrote the schema, like somehow the data got into the database, but who put it there, like who made those decisions? Why did they make those decisions? Going back to that mind map, like who decided to do it this way? Why did they, like really picking that person's brain? If the person's not there, did they have a blub? Or if someone else is on their team, like asking them, like really figuring out why is the data there? Like there's a reason that someone chose to like track how many people in California buy Nike Frees from this particular store on this day. Right? There's a reason that data is there. Figure out why it is, and then try to, come up with a business solution to like why it's there and why it would be useful. Instead of just like waiting for the answers, because people from higher levels will come and say like, oh, we want to know about this. But they don't understand like what data is in the database, like why it's there, how to put the data together. It's sort of like if you were to have like an outfit, right? But all of your clothes are scattered around your whole house, so you have to go like into the kitchen to find your socks, and go, into the bathroom to get your hat. You have to go into all these different rooms to actually get dressed. It's sort of like that data and databases. I mean, I literally had like 36 joins just to run one query. That was one piece of middleware, and I had 4 pieces of middleware. So it was a lot of things happening